Hey guys, today we're going to be talking about electrical charge and force, so get excited for that. Okay, so the first thing I wanted to do is I wanted to talk about kind of when we talk about this phrase, opposites attract and likes repel. As you might know, opposite charges would be like a positive charge versus a negative charge. But if they were the same charge, they could either be two positive charges, like what we see here in the middle, or two negative charges. Those would both be considered like charges because they're the same. What we're going to see here is that the opposite charges, when we have a positive and a negative charge, they are going to attract. So you see those two green arrows right there showing they're going to smush together. This is kind of like if you put two pieces of magnets together and they'll attract each other. They'll kind of stick together. Now, if you flip one of the magnet sides, then instead of them both sticking together, they'll actually both repel. So if you try to push them together, they'll kind of go the opposite way. That's also true with electricity. We'll notice that if we have two of the same sides, for example, two positive charges, they will repel. Or if we have two negative charges, they will repel. So we see this with a magnet as well. If you have two sides that repel, maybe you have like two north ends facing the same way. If you flip both of them around, they'll still repel, right? Because either way, you're having them both face the same side, so they're both positive or they're both negative. We see the same thing with electricity. They have to be opposite in order for them to attract. So we kind of summarize this whole thing as opposites attract, likes repel. Now, here are two objects. Now, an object is different than just like a charge, right? Because an object is going to have a bunch of these positive charges and a bunch of these negative charges. And what we'll see is that sometimes an object will have more of one or less than one. And that's what this is kind of saying here. Electrical charge is caused when an object has a different number of protons and electrons. Protons, remember from our atom stuff, are the positive things. Electrons are, of course, the negative things. So an object might have like 5 pluses and 5 negatives, or 5 protons in orange here and 5 electrons in blue here. And this would be a neutral object because the total number of positives is the exact same as the total number of negatives. So you'll see down here I wrote neutral object. Now, keep in mind here, if the object only had 5 protons and 5 electrons, it would be like the size of an atom. So most objects have like trillions and trillions of positive protons and negative electrons. Um, and yeah, for example, this object here will show that it has 5 protons and only 3 electrons. So this object, we could say, has a -2 or a +2 charge. +2 because it has, these 2 extra pluses versus electrons. And so yeah, this object would be positively charged. So when we think of objects and their charges, don't think of them as only having positive charges or only having negative charges. Think of them as having a combination of both, but one is more or one is less. Yeah, so we're going to be using these terms conductors and insulators as we move forward. We've talked about these when we talked about heat. Remember, a conductor is something that's going to allow heat to flow very quickly. It's the same thing with electricity. A conductor is something that's going to allow electrons to move very easily, versus an insulator doesn't allow those electrons to move. Now notice here as I'm talking about electrons. Protons don't move. They'll just kind of stay where they are in the atom, just because they're part of what makes the atom the actual atom, or these protons are what makes, the object, the actual object, I should say, not the atom. So protons can't move, but electrons can. And we'll notice that in conductors, they'll move a lot, but in insulators, they won't move as much. So yeah, we're going to kind of follow the electrons here. There's 3 ways to transfer electrons. We can do that through friction, through induction, and through conduction. And now, just because we're only transferring electrons doesn't necessarily mean that things will only become negative. Remember, if one thing is losing electrons, that means it's going to give electrons to one thing, making it negative, but then the thing that gave away the electrons will become positive. Kind of like when we talked about ions, metals give away electrons and nonmetals accept electrons, and then the nonmetal usually has a negative charge, but the metal ends up with a positive charge, right? So just keep that in mind as we're talking about electrons being transferred. So one way you can do that is through friction. If you've ever put on some really fuzzy socks and kind of rubbed your feet against the carpet, maybe you're like running up and down, I don't know, a carpeted hallway, you'll notice that you build up electrostatic friction. So what that means then is if you accidentally touch something metal, you might give yourself a shock, or if you touch your brother, you might shock your brother. And that's just because as you're moving, your socks, your fuzzy socks, are kind of gaining up a bunch of electrons, which gets transferred through the rest of your body. So then as that charge builds up, you can actually shock someone because of it. And then that'll depend on what type of material you're rubbing. So for example, you can rub wool onto glass, and then the glass actually becomes positive, or maybe it becomes negative. I don't know. But yeah, depending on which materials are rubbing with which other materials, that'll tell you kind of how the electricity transfers. So yeah, friction's one way to do it. Now, the next way is a little bit more complicated. It's more complicated than just friction is rubbing and you produce electrons. This is called induction. So what induction means is you take a charged object. Here's my charged object. It's a cylinder. In this case, you'll notice that it's negatively charged because it's got way more electrons, way more negatives than it has protons, those positives. And then you'll notice here that I have a neutral object where for every one plus, I have one minus, I think. I'm pretty sure they're even. So my circle here is neutral. My negative object is my little cylinder here. Now, what I'm going to do is I'm going to take my charged object, my cylinder, and I'm going to move it closer to my circle. So I'm going to go ahead and do that. And this is actually induction. So you'll notice there's no change yet. I'm going to show you the change that happens in a little bit. This is induction when I take a charged object and I put it near a neutral object. And this is what happens in induction. Notice how the electrons here, I'm going to show it again, kind of move away. So there's kind of a separation. And notice my protons are staying in place. It's just my electrons that are kind of moving from one place to the other. And now they're all kind of on one side. So this really negative area is forcing those electrons to kind of move away. And that's going to create a polarized area. Polarized means I have one area that's super, super positive. So in this case, it's the left side of the sphere. And then I have the other area, the right side of the circle, that's really, really negative. And that's just because I have way more negatives than positives. So that's what polarized means, and I'm going to show the definition now. It's a split location of, negative and positive charges. So this is what happens in induction, is if you induce an area, it'll become super, super positive and super, super negative. The last thing that we have to talk about is we have to talk about conduction. And conduction is what happens if I actually take this negative object and touch this neutral object. So we're going to go ahead and show that. Well, bam, they've made contact. Now what's going to happen is some of these electrons here are actually going to transfer over. So with the contact then, we get these three electrons to kind of transfer over into the neutral object. So now they both kind of, this negative object becomes less negative, and this neutral object is going to have some extra electrons, meaning that now it's going to be slightly negatively charged. So it's no longer neutral because it has those extra three electrons. So in general, here's what happens. If you touch a neutral object with a negative object, it's going to become more negative. It's going to be given electrons. But if this object wasn't negative, if it was positive instead, then the positive object will end up taking electrons away. Because remember here, the protons, the positive charges, aren't moving. It's just the negative charges. So kind of what's happening here, if I can go back a little bit, is as they touch here, we have this super negative object and this super positive side. So kind of what the electricity is thinking is, we want to be even, we want to be equal. So what it does then is it's like, okay, I'll give you, 3 electrons so that, these are both now equally negative. And then they'll kind of split up. So yeah, the key here is negative objects give electrons, and if you have a positive object, it will take electrons away from the neutral object. And that's conduction. So there you have it, guys. Those are the 3 different types of energy transfer. We've got, conduction, induction, and friction. That's all the time we have for today. So I hope you guys learned something. And yeah, have a good rest of your day. We'll see you next time.